All right, this video is for section 4.1, angles and radian measure. Your essential question, and ignore the grammar, but it is what is a radian and how does it relate to a degree? If you want to look over here to the left, there's just the objectives that we're going to look at over the entire section, but we're going to focus on number 2 and 3, number 4, number 5, and number 6, and then we'll look at the other ones in part 2. So going back to angles, first we're going to look at the precise definition of an angle. So that's two rays, so I have here ray BA and ray BC, that are connected by a common endpoint. And we measure an angle, and we always start with the initial and move towards the terminal side, and that measurement is going to be our angle, and this here is the Greek letter theta. Okay. And you'll see that quite a bit, but sometimes the variable that you use can be different. Okay, so an angle is in standard position if and only if the vertex is at the origin of an XY graph and the initial side lies along the positive x-axis, which means every single time the vertex has to be right here. And every single time the initial side has to be here. It can't be anywhere else. So we look at this first graph, the terminal side is in quadrant 2, so that angle alpha right here is this angle here. Angles that go counterclockwise are always positive. So, and I'm going to write it anti-clockwise. All right, that's going to give you a positive angle. Clockwise, that's going to give you a negative angle. Okay, so here for angle theta in the second graph, that's a negative angle because it's going this way. We could measure in this direction and get a different angle value that's positive, but here we're just measuring negative angles. And this slide here basically just redefines what we know from geometry. An acute angle is somewhere between 0 and 90. A right angle is a 90 degrees. An obtuse angle is somewhere between 90 and 180. And of course, a straight angle is 180 degrees. We typically don't define angles that are bigger than 180 using some sort of name. Those are typically always between 0 and 180. Okay, so this slide's a little small at first, but we're going to formally define a radian. So if I have a circle right here where the two radii and this little arc that would connect the two radii, if everything has the same exact distance, we will define that this little value right here is going to be 1 radian. And later on you'll see that 1 radian, so I'm going to want 1 rad, is approximately 57.3 degrees. And you'll see how to calculate that later on. Okay. More formally, if you look at down here now, we have a little formula here that says theta is equal to s, which is our arc length, divided by the radius, which is radians. We will use this more in section or in part 2 of this video, but for now we're just going to go ahead and ignore it. So now we're going to look at the relationship between degrees and radians. Okay, so basically what we're going to be doing is you'll need to be comfortable to freely convert between the two different measuring types. So if I look here in the first line, to convert from degrees to radians, we multiply whatever angle we have by pi over 180. To convert from radians to degrees, we multiply by 180 over pi. So you have to ask yourself, when you look at these two things, what do you notice? Okay, so hopefully what you notice is whatever you're converting to, so I'm going to write here, this is what we're going to, and this is what we're coming from. Here, this is what we're going to, and there what's we're going from. Okay, so keep in mind, the measure that we're going to is what's going on top. Radians are typically expressed in terms of pi, where degrees are typically represented with a degree symbol. So, for example 2, what we're going to do is we're going to convert 30 degrees to radian form. So we'll start with our 30 degrees. Okay. And then it says to convert from degrees to radians, we multiply by pi over 180. Okay, so when I get that multiplied out, I get 30 pi over 180. And note that our two degree symbols here, this degree and this degree, kind of cancel each other out. By simplifying, I know that 3 goes into 18 6 times, and then the zeros cancel out, so we're going to be left with pi over 6 as our radian measure for 30 degrees. So here we know that 30 degrees is equal to pi over 6. Okay. I'm going to skip part B because we're going to do that later. For part C, I want to convert negative 135. So we do that by multiplying by pi over 180. And then I'm going to simply write negative 135 pi over 180. Okay, and remember, what we have to do to reduce this is to find the biggest common factor we have between the two. And if we don't know that, we can simply start by dividing by 5. So if I divide by 5 here, both the numerator and the denominator, I get negative 27 by over 36. And then I look at this again, and 27 and 36 are both divisible by 9. So that'll give me negative 3 pi over 4. Okay, so what that tells me is negative 135 degrees in degree mode is equal to negative 3 pi fourths in radian mode. So on this next page, I'd like you to pause the video, try doing these conversions out, and then when you unpause it, you'll see all the solutions at one time. Okay, so did you get them right? So for part A, it's 60, and then that is going to be equivalent to pi thirds. For part B, 270 degrees is equivalent to 3 pi halves, and negative 300 degrees is equivalent to negative 5 pi thirds. Okay, so for example 3, we're going to go back the other way. So what we're going to do is I'm going to do part A and part B, and then we're going to leave part C since we showed you that, since I already told you that this is equal to 57.3 degrees. Okay, and what I will point out is these two you're expected to do without a calculator, and anytime you have just like 1 radian or 2 radians, we typically use a calculator to find those. So for part A, if we start with pi thirds radians, so pi thirds times, and then remember we're converting to degrees, so the 180 degrees goes on top, pi goes on the bottom, which this gives us, when the pi's cancel, 180 degrees divided by 3. And 18 divided by 3 is 6, so that's going to give us 60 degrees. For part B, negative 5 pi thirds times, again, 180 degrees over pi. Our pi's cancel, giving us negative 5 times 180 over 3. So typically here, people will multiply the 5 and the 180 together, but I don't think that's the easiest method. I think the easiest method is doing this division first and then multiplying that result by 5. So here, we're going to have negative 5 times 60 degrees, which is equal to negative 300 degrees. Okay, and then here's what I want to warn you. When you're converting to degrees, you will be marked wrong if you do not put this little symbol, okay? So here, in this type of measurement, 300 degrees is not the equivalent of 300, okay? We say that radians are a unitless measure, and by doing that, we always assume that there is no degree symbol. It is actually in radian mode. So here, while you see here 300 degrees, this is technically 300 radians. So remember, when you're converting to degrees, don't ever forget your little degree symbol. All right, so try part A and B. For part C, you can use a calculator. And go ahead and pause the video, give them a try, and when you unpause, you should see the solutions. Okay, so how'd you do? So for part A, we basically, again, multiplied everything by 180 over pi, leaving us 180 over 4, and then I know that 45 times 2 is 90, so 90 times 2 is 180, so I know that that's equal to 45 degrees. For part B, again, the 2 pi's canceled out, leaving us with 4 times 180 divided by 3, and then I divided this to get 60, and 4 times 6 is 24, and then add on the 0. And then for this part here, I just used the calculator. So I got 1080 over pi using my calculator, and then I hit the Control-Enter, and writing it to one decimal place, I get 343.8 degrees. All right, so when we're asked to draw angles in standard position, it takes some intuitive use of fractions to help you draw these things. So let's remind you that one complete revolution around is going to be equal to 2 pi radians, or 360 degrees, but we're going to focus on the radians here. So down on the bottom, I'm going to quickly draw an axis. And when we label this xy axis and we figure out our angles, this angle here, where we start our measurement, is always going to be 0 or 2 pi, which represents one complete turn. The top is going to be pi halves, then it's going to be pi, and then it's going to be 3 pi halves. Which here what we have is we just divided 2 pi into 4 equal segments. So if I were to sketch, say, pi, my initial side starts here, my terminal side ends at pi, and it goes like this. Okay, so that's very similar to what you see in this. It's actually exactly what you see in this picture here. So we're going to look at ways to draw angles in standard position. So here we'd like to do, and what's nice here is the book has actually done a really good job of telling you this is the angle theta, this is alpha, this is beta, and this is gamma. They picked 4 so that way you could just have nice 4 easy graphs. What I'm going to do, however, is I'm going to draw one graph with all 4 angles on it. So let me draw some axes. So good thing these axes come already labeled, and I want to sketch pi fourths. So through fractions, pi fourths is actually half the distance of pi halves. So I'm going to sketch my initial side, and again, the initial side is always right there on the 0 axis, and then I'm going to go halfway in between 0 and pi halves, and now this angle right here is the angle theta, or pi fourths. For 5 pi fourths, if I kind of count, so if this was 1 pi fourths here, this is technically 2 pi fourths. If I go right here, this is 3 pi fourths. 4 pi fourths is equal to 5, so 5 pi fourths needs to be right here. And I'm going to sketch that in blue, keeping the same initial side. So this angle right here is going to be the angle alpha. So that takes care of those two. Now, remember here, we have negative 3 pi fourths for beta. So remember, we're going in the opposite direction. So for this one, again, here's negative 1 pi fourths, here's negative 2 pi fourths, and oh look, here's negative 3 pi fourths. So I'm going to draw from here this is the angle beta, okay? Now, we're going to throw out a word here that we're going to talk about in a few minutes. Because alpha and beta have both the same terminal point, or terminal array, we call them coterminal angles. So, beta and alpha, these two are, change the color, these two are coterminal. Okay, and we'll get into more of that in a minute. And then for the last one, this is gamma is equal to 9 pi fourths. So here, when I do this, 9 pi fourths is actually going to be more than one revolution. So I have 1 pi fourths, 2, 3, 4, 5, 6, 7, 8. So 9 is going to be here as well. And when I draw this out, I'm going to start right here. Gamma is going to be this angle right here. Okay, so that's the angle gamma. All right, so I'd like you to take a moment and sketch all 4 of these angles on the same axis, or you can use separate ones if you like, and go ahead and pause the video, and then when you come back, you'll see all the solutions. So what you have here, if you used one graph, is one incredibly messy graph. So for negative pi fourths, remember negative angles go in the negative direction or the clockwise direction. So that's why pi fourths is here. 3 pi fourths is 1, 2, 3 pi, right there. There we go. Negative 7 means I go 1, 2, 3, 4, 5, 6, negative 7. So that's why the purple beta is here. And then for 13, 8 is one complete revolution. 8 pi fourths reduces to 2 pi. And then we have 5 left, so it's 1, 2, 3, 4, 5. So gamma is one complete revolution plus almost a second one. So I kind of alluded to this before. A coterminal angle, or an angle is coterminal with another angle if they have the same terminal side. So typically what we do is if we're in degree mode, we can create coterminal angles by adding 360 degrees or 2 pi radians. And in doing that, that just adds one revolution from where the terminal angle was. So for this problem here, for example 5, is we're going to assume that they're in standard position, and we want to find a positive angle that's somewhere between 0 and 360 for 420 degrees. So what we want to do here is, because 420 is greater than 360, we want to subtract out 360 from 420. So if I subtract out 360 degrees, I get 60 degrees. So that tells me that 60 and 420 are coterminal. Okay. For the second one, I have negative 120 degrees. And because I need to get to somewhere between 0 and 360, I need to add 360. So here, this gives me 240. So this tells me negative 120 and 240 are coterminal. Now, what I want you to keep in mind is sometimes you might have to add or subtract 360 more than once, but we didn't have to in this problem. So for checkpoint 5, please find 2 angles, one being coterminal to 400 and the other one being coterminal to negative 135. When you unpause the video, you will see the solutions. Okay, so hopefully you got the same answers. In the first one, we just subtracted 360 degrees to get 40 degrees. telling us that 40 degrees and 400 degrees are coterminal. For the second one, we added 360 to negative 135 to tell us negative 135 degrees is coterminal to 225 degrees. So example 6 is the exact same problem, but now in radian mode. So here we're going to add and subtract 2 pi. So for part A, I have 17 pi sixths. So what I'm going to do is I'm going to take 17 pi sixths and subtract 2 pi. Now, that's not in a form that's very easy. So what I'm going to do is I'm going to express 2 pi in terms of sixths. So 17 pi 6 minus 12 pi 6. And please keep in mind, this number will always be double this number for 2 pi. So that tells me that 17 pi 6 and 5 pi 6, those two are coterminal. Okay, so for the second example, we start with negative pi twelfths. And here we're going to add 2 pi, which is negative pi twelfths, plus 24 pi twelfths, because that's 2 pi in twelfths, which is going to give us 23 pi twelfths. So negative pi twelfths and 23 pi twelfths are coterminal. And remember, coterminal means both of these angles share the same terminal array. All right, so go ahead and try these two. Remember, when it's positive, you're adding or you're subtracting 2 pi, and when it's negative, you're adding 2 pi. So go ahead and pause the video after you try, and then after you try it, unpause it, and you'll see the solutions. Okay, hopefully you were right. So for the first one, we subtract 2 pi, and when we do that, we get 3 pi fifths, telling us that 13 pi fifths and 3 pi fifths are coterminal. For the second one, we added 2 pi to get 29 pi fifths, and that tells us that negative pi 15ths and positive 29 pi 15ths are coterminal angles. So example 7 kind of mixes them, but now what we're going to do is we're going to have to add or subtract 2 pi more than one time. So for 750 degrees, here I need to subtract 360 like we have in the past. So 750 minus 360, that gives us, carry the 1, 390 degrees. That's not less than 360, so I need to do it one more time. And that gives us 30 degrees. So here, 750 and 30 are coterminal. Okay. For the second example, we're at 22 pi thirds. And I need to subtract 2 pi, but in terms of thirds, it's 6 pi thirds. When I do that, I get 16 pi thirds. Now, I need an answer that's less than 6 pi thirds, so I'm going to keep subtracting 6 each time. So when I do that, I get 10 pi thirds. And then I get 4 pi thirds. So what that tells me is 22 pi thirds and 4 pi thirds are coterminal. And that's not to say that it's also coterminal with 16 pi thirds and 10 pi thirds. Every single one of those angles are all coterminal. In the interest of time, we're going to skip part C. If you want to find part C, if you look at your book, you can see the solution to that. Okay, and then so for checkpoint 7, I'd like you to try all 3 of these, see if you get the right solutions, and then go ahead and pause and then unpause the video after you have a go. Okay, so for the last one, let's see how you did. So we have 855 degrees, so we had to subtract 360 2 times to get 135 degrees, telling us that 855 and 135 are coterminal. For the second one, we had to subtract 2 pi twice, which is 6 pi thirds. First time to get 11 pi thirds, second time to get 5 pi thirds, telling us 17 pi thirds and 5 pi thirds are coterminal. And then for the last one, we had to add, in this case, 12 pi 6, and we had to do it 3 times to get a positive angle. So here, it tells us negative 25 pi 6 plus 11, and 11 pi 6 are coterminal. So here, the homework for this section is on page 473. Please do 13 through 17, 21 through 25, 41 through 45, 53 through 56, and 61 through 64.